Hello everyone. Let us start exercise 8C, numerical number 1. An electric bulb of resistance 500 ohm draws a current 0.4 ampere. Calculate the power of the bulb. So here, based on the information given, we can use the formula P is equal to I square R. Current is 0.4 into resistance is 500 ohm. So this is 4 by 10 into 4 by 10 into 500, which is 80 watt. And the potential difference at its end, V is equal to IR. Current is 0.4, or we can say 4 by 10 into resistance is 500. So this is 200 volt. Second numerical. A current of 2 ampere is passed through a coil of resistance 75 ohm for 2 minutes. How much heat energy is produced? So for heat energy, here we can use the formula H is equal to I square RT. Okay, we know that when current flows through a conductor, some amount of energy is produced in terms of heat, some amount of energy is lost in terms of heat. And for that, we can use the formula I square RT. Current is 2 ampere, so 2 into 2, resistance 75 ohm, and time is given in minutes, which must be converted into seconds. So 2 into 60, which is 75 into 8 into 60, and this answer is 36,000 joule. B. How much charge is passed through the resistance? So Q is equal to current into time. Current is 2 ampere and time is 2 minutes or 120 seconds. That is 240 coulomb is the charge. Third, calculate the current through a 60 watt lamp rated for 250 volt. So power is 60 watt, or we can say 60 joules per second. So this bulb consumes 60 joules energy per second only when it is connected to 250 volt. Alright, that is the meaning when we say it is rated for 250 volt. So using this information of power and voltage, we can find current, that is P upon V. Power is 60, voltage is 250, 6 upon 25, 0.24 ampere. 0.24 ampere is the current. Now the question also says that if the line voltage falls to 200 volt, how is the power consumed by the lamp affected? Let's say initial power is P1 and initial voltage is V1. Now voltage drops to 200 volt. So what is a new power? Okay, what is a new power? That is what we want to figure out. So by changing the voltage, power changes, but one thing remains constant, that is the resistance of the filament. Okay, resistance of filament does not change. Resistance of the filament remains constant. So we can use this particular fact to find out new power. P is equal to V square upon R. So from here we can say R is equal to V square upon P, and that is constant value. So V1 square upon P1 is equal to V2 square upon P2. V1 is 250, so 250 into 250 upon power is 60 watt is equal to V2. V2 is 200, so 200 into 200 upon P2. So when I make P2 as a subject, it is 200 into 200 into 60 upon 250 into 250. And after simplifying this, we get the answer 38.4 watt. Fourth, an electric bulb is rated 100 watt 250 volt. How much current will the bulb draw if connected to a 250 volt supply? So here bulb is connected to the voltage which is mentioned in its rating. So we can use the formula directly. I is equal to P upon V. Power is 100 watt and voltage is 250. So this gives us the answer 0.4 ampere. Easy, isn't it? Fifth, an electric bulb is rated 220 volt 100 watt. What is its resistance? Alright, so P is equal to V square upon R. Resistance is equal to V square upon T. Voltage 220 into 220 upon power is 100. So this gives us the answer 484 ohm. And what is the safe current limit? V is equal to IR. Voltage is 220 is equal to current we want to find out, and the resistance is 484. So here current is equal to 220 upon 484, which is 0.45 ampere. Or we can solve this question using this formula as well. P is equal to VI. Power is 100 watt, voltage is 220. So this will also give us the same answer, 0.45 ampere. Sixth, a bulb of power 40 watt is used for 12.5 hours each day for 30 days. Calculate the electrical energy consumed. Electrical energy E is equal to power into time. Power is 40 watt into time is 12.5 hours a day. But the bulb is operated for 30 days. So we must multiply with 30 as well. So here unit becomes watt into hour. Okay, so we have to convert this watt into kilowatt. So if I divide 40 by 1000, watt gets converted into kilowatt into 12.5 into 30 hour. So unit is now kilowatt hour. And this answer is 15 kilowatt hour. 15 kilowatt hour. Seventh, electric press is rated 750 watt 230 volt. Calculate the electrical energy consumed by the press in 16 hours. Again, energy is equal to power into time. Power is 750 watt. Time is 16 hours. So this is watt into hour. Convert watt into kilowatt. 750 upon 1000 into 16. So this is kilowatt into hour. And that answer is 12 kilowatt hour. Eighth, an electrical appliance having a resistance of 200 ohm is operated at 200 volt. Resistance 200 ohm operated at 200 volt. Calculate the energy consumed by the appliance in 5 minutes in joule as well as in kilowatt hour. So first let us find out the energy in joule. Energy is equal to power into time, but here power is not given directly, so we have to use the formula V square upon R for power into time. Voltage is 200, so V square here we have 200 into 200 upon the resistance is 200 into time is 5 minutes into 60 seconds. So this is 200 into 5 is 1000 into 60, so 60,000 joules. Now we know that 1 kilowatt hour is equal to 3.6 megajoule, or we can say 3.6 megajoule is equal to 1 kilowatt hour. So 60,000 joule is equal to how many kilowatt hours? 60,000 into 1 upon 3.6 mega is 10 to the power 6. So on simplifying this we get 0.0167 kilowatt hour. Ninth, a bulb rated 12 volt and 24 watt operates on a 12 volt battery for 20 minutes. Calculate the current flowing through it and the energy consumed. Current flowing through it first, that is using the formula P is equal to VI. Current is equal to power. Power is 24 watt upon voltage is 12, so 2 ampere. And the energy consumed, energy is equal to power into time. Power is 24 watt, time is 20 minutes. So unit is watt into minutes. To convert watt into kilowatt, divide 24 by 1000. So what is converted into kilowatt? And to convert minute into hour, divide 20 by 60. So minute is converted into hour. 23, 3 8s are 24. So this is 0.008 kilowatt hour. So here energy unit is not specified in the question, that in which unit you are supposed to find the answer. So you have a liberty to find the answer either in kilowatt hour or in joule. If I convert this kilowatt hour into joule, I simply will have to multiply with 3.6 megajoule. So 3.6 into 10 raised to 6 joule, which is 28,800 joules. 10th, a current of 0.2 ampere flows through a wire whose ends are at a potential difference of 15 volt. Calculate the resistance of the wire and the heat energy produced in 1 minute. So to find out the resistance of the wire, we can apply simple formula. R is equal to V upon I. Voltage is 15, current is 0.2, which is 150 divided by 2, 75 ohm. And now to find out the heat energy produced in 1 minute, we can use the formula E is equal to, here we have to use the formula V square upon R into T. Voltage is 15, so 15 into 15 upon 75 into time is 1 minute, or we can say 60 seconds. 5, 5, 3s are 180 joule is the answer.
Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.